Watch an octopus encounter a seemingly impassable barrier in the rocks. It doesn't break through or climb over, it simply compresses its entire body into an opening the size of a coin and flows like liquid to the other side. Welcome to my YouTube channel. Out in the open ocean, an octopus is effectively a floating, shell-less meal. It is a highly nutritious, soft-bodied target navigating a habitat completely surrounded by predators, equipped with dense bone, thick armor, and sharp teeth. To stay alive against those physical odds, without a rigid skeleton of its own, this mollusk was forced by natural selection into becoming the ultimate biological escape artist. This diagram shows a cross-section of octopus skin. Those tiny pigment sacs are called chromatophores, and each one is directly wired to the animal's nervous system, allowing it to instantly expand wide based on a direct neural impulse. By activating thousands of these sacs at once, the octopus can shift its skin color and even manipulate its physical texture in milliseconds, allowing it to vanish perfectly into the surrounding reef. Some species take this biological machinery a step further. The mimic octopus alters its shape and color pattern to actively impersonate other animals, successfully passing itself off as a venomous sea snake or a toxic flounder to terrify specific predators. Because they have no rigid shell or skeleton to protect them, they are absolutely free to squeeze, stretch, and dramatically shapeshift in ways no armored predator could ever follow. If an octopus is spotted and cornered, that lack of bones transitions into a mechanical advantage. It compresses its internal organs, slipping out of any trap or crevice as long as the opening is wider than its parrot-like beak, the only rigid piece of anatomy. It can also deploy a specialized defensive cloud. This ink contains tynglucinase, a chemical compound that physically blinds an attacking predator while actively destroying its sense of smell. If physical combat is unavoidable, the defense escalates to lethal neurotoxins. The blue-ringed octopus utilizes tetrodotoxin, a venom capable of causing rapid respiratory failure in attackers. They apply a similar chemical strategy to their prey. They bite down on a crab, inject potent enzymes, and literally liquefy the meat inside the shell so they can consume it like a protein smoothie. Even if a predator manages to grab hold of them, a juvenile octopus can simply detach the trapped arm to secure its escape, and then fully regenerate the missing limb later. The same specialized glands and neural circuits that hide the octopus also provide the arsenal for its active chemical defense. If you're enjoying this video and haven't subscribed to my channel yet, now's the perfect time to hit that subscribe button. It really helps the channel grow and lets me bring you more amazing content like this. Keeping a highly active, shape-shifting body fully oxygenated in deep water requires extreme circulation. To achieve this, an octopus operates on 3 distinct hearts, 2 dedicated entirely to pumping blood through the gills, and 1 main systemic heart to supply the rest of the body. Interestingly, that main systemic heart stops beating entirely when the animal swims. Fast swimming quickly exhausts them, which is why you almost always see them dragging their soft bodies across the ocean floor to conserve energy. Inside those blood vessels flows a copper-based blue blood called hemocyanin. While human blood relies on iron, this copper chemistry is vastly more efficient at transporting oxygen in the freezing, low-oxygen environments of the deep ocean trenches. Every piece of their internal plumbing operates as a highly customized engine, built specifically to keep a soft body moving under immense ocean pressure. The network controlling this engine consists of roughly 500 million neurons. The central brain is actually shaped like a donut, positioned right between the eyes, and bizarrely, the animal's esophagus runs directly through the center of it. This visualization compares a mammalian brain structure with an octopus's decentralized nervous system. Rather than housing all its processing power in its head, the octopus has 2/3 of its neurons distributed across its 8 arms, effectively operating as independent satellite brains. The central brain dictates the overall strategy, issuing a high-level command like hunt. The arms then take over, using their own dense local neural circuits to taste the water, feel the texture of the rocks, and adjust their grip, all without requiring micromanagement from the head. This distributed intelligence drives incredibly complex behaviors. In laboratory settings, they easily recognize individual human faces, And in the wild, the veined octopus actively collects and carries coconut shells to use as a mobile shield against predators. They saw as their mind is spread entirely throughout their limbs, establishing them as the smartest invertebrates on Earth. Despite their remarkable intelligence and physical adaptability, an octopus rarely lives longer than 1 or 2 years. Reproduction functions as a biological death sentence. For males, the act of mating, which involves transferring sperm using a specialized reproductive arm, leads to rapid physical deterioration, and they die shortly after. The female's trajectory is equally grim. After laying up to 400,000 eggs, she completely stops eating. She spends the remainder of her short life obsessively guarding the clutch, pushing fresh water over them to keep them oxygenated. This starvation is a programmed chemical self-destruct sequence. Triggered by her optic gland, her body disrupts its own nutrient processing and surges with steroid hormones, causing her to rapidly waste away. A creature that evolved to outsmart nearly every threat in the ocean dedicates all of its gathered energy into a single reproductive event, sacrificing the individual to ensure the next generation survives. Decades of research have mapped the octopus's hearts, nerves, and camouflage, but recent genetic discoveries reveal a mechanism that operates unlike almost anything else on Earth. While most life is locked into the genetic instructions found in their DNA, octopuses can actively rearrange the molecular blocks of their RNA. By dynamically editing these genetic messengers, they can rewire their nervous system's response to environmental changes, like temperature shifts, without waiting for generations of evolution. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating wildlife, science, and nature stories. See you in the next video. As long as the ocean remains a hostile, high-pressure escape room, the octopus will keep rewriting the rules of survival.